Hello students, welcome to our class. So we have already finished motion yesterday, right? So what did we learn in motion? Let us look at it once again. So describing about motion, it was done by Ankit sir, right? So you already have to know what is motion. You know, anything a body is moving, then it is called motion. And being in motion means changing position from one position to another in a given time, right? So we have learned about this. So in this chapter we were discussing mostly about the straight line motion. So about the straight line motion, what did we learn? So about straight line motion, we have learned a lot of things that we will be discussing now again. Not discussing, we'll just revise. Okay, so we have seen that uniform motion and non-uniform motion. You know what is a uniform motion? If a body covers equal distance in equal interval of time, then it is uniform motion. And non-uniform means unequal distances in equal interval of time. So this was about uniform motion. We have also learned about speed with direction. Speed with direction means about the velocity. So velocity has both speed as well as direction, because the average speed does not give us the direction about of the object moving. So we also need about direction. We have to know where the object is going, right? So for this we take the help of velocity. Velocity is the displacement per unit time. Why do we use displacement? Because displacement has a particular direction, but distance does not have a particular direction. Particular direction is necessary in a straight line motion so as to get the speed or velocity. So speed is giving us the rate at which the body is covering certain distance, and velocity is giving the rate at which the person or an object is changing the position from one place to another in a particular direction. Okay, so we have also discussed about the rate of change of velocity. What is rate of change of velocity? It is the acceleration. So acceleration is the rate of change of velocity. We have done a lot of problem and we have known that mathematically acceleration is change in velocity per unit time. So we can change this as a is equal to v minus u divided by t. So a equal to v minus u divided by t. V minus u means the change in velocity. Change in velocity means final velocity minus initial velocity. So this kind of motion is the accelerated motion. You know about accelerated and deaccelerated motion, right? Accelerated means going from slower to fast. Okay, object is moving in a speed something like in the beginning 1 meter per second, and after some time it becomes 10 meter per second. That means it is increasing by some amount at every second, right? So in this manner only deacceleration means firstly the body was in a higher speed, then I think maybe like the brakes are applied on it, then it slow down, and finally it comes to rest, or may not come to rest, it may again, but after all the speed decreases. So when this happens, it is deacceleration. We have also known about it. We have solved a lot of problems. I hope you have solved all the problems I have given. Try as much problem as you can. So graphical representation of motion, we have learned about the distance time graph. In a distance time graph, we have the for uniform motion it is a straight line, and for non-uniform motion a graph can be of any shape, maybe any curve, but it is not a straight line. Okay, so this was about distance time graph. For uniform motion is a straight line, for non-uniform motion it's not a straight line, it can be like a curve. Okay, so we have also learned about the velocity time graph. Velocity time graph I have given you different in a chart. Okay, you know which type of graph gives which condition gives which type of graph. Like the velocity time graph for uniform motion is a straight line which is parallel to the time axis. So this is the time axis and this is the graph. Okay, this graph is parallel to the time axis. Why? Because it was at rest, because the body is at sorry, not rest, body was at a constant velocity. Rest means in this case you can see in distance time graph, if I ask you in distance time graph, if some graph is which is parallel to the which is parallel to the time axis in a distance time graph. In a distance time graph, if something is parallel, then the body is in the same distance for long. That means what is the meaning of the thing that you are in you are 10 kilometer away from me for 10 minutes. That means you are on the same position for the 10 minutes, right? That is what happens. So this is it on a straight line, okay, on a straight line only. So on a straight path, there is a straight path, and you are 10 kilometer away from me. That means you are not moving. You are for 10 minutes, say you are staying in the same position, then for 10 minutes only you will be in the 10 kilometer away from me only. So this is, that means that body is in rest, that body is in the same position. So in distance time graph, if the graph is parallel to the time axis, that means the body is at rest. But in case of the velocity time graph, you can see velocity, this the y-axis, the numbers in the y-axis gives us the velocity. It tells about the velocity. So this is 40 kilometer per hour. That means the body is constantly at a 40 kilometer per hour for some time, like in hours 1 2 3 4. So for 4 hours the body is in the constant velocity, right? So for this manner only, for this only, this is a graph of uniform motion. It is in a constant velocity motion, the constant velocity or constant speed motion. Then this is a straight line which is parallel to the time axis. So velocity time graph we have discussed. We have also discussed about the velocity time graph for uniform motion, uniform acceleration. Uniform acceleration, now what is uniform acceleration? If the velocity changes in equal manner in every equal interval of time, then the acceleration is uniform, right? So what is non-uniform acceleration? Then that means the change in velocity is not same for equal interval of time, right? For this now graph, let us see. This is a non-uniform motion because the body is not at say covering equal distances in equal interval of time, but it is having some good criteria here. You see, after every equal interval of time, the distance covered is increasing only. Not it is like after 1 minute the distance is very high, and in the next 1 minute the distance covered is very less, and again high and again less. It is not like that. It is constantly increasing only. That means this is a non-uniform motion, but uniform accelerating motion, uniformly accelerating motion, right? So for this the graph is a straight line which is looking like this, and the distance covered we can find out from this graph only. How do we find the distance covered? Pick any 2 points or whatever point you want, then you find the area under this straight line or the straight line segment. Okay, the line segment, you find the area under that line segment, you get the distance covered by the object. Similarly, in the deaccelerated motion, the graph looks like this, and then if you want to find the distance covered, then same thing you can do. Pick any 2 points, find the area, then you will get the uh, displacement or the distance. If it is a speed time graph, you can find the distance. If it is a velocity time graph, you will find the displacement. All these are for only the straight line motion. So we have been doing the things only for the straight line motion most of the time. Okay, so this is the velocity time graph for non uniformly accelerated motion. This graph can look like anything, maybe this like, but it is not looking always the same like the uniform accelerations and these two. Okay, deaccelerated, uniformly deaccelerated are always the straight line, but for non-uniformly accelerated motion, it is never the same graph. Okay, the different conditions, the different data will give us the different graph for non-uniformly accelerated motion. So now we have also come across the equation of motion. We have not proved this. We will prove this in school. I have thought about this. So better first of all, to solve the problem, we only need the equations of motion. So there are three equations of motion which are v equal to u plus at, s is equal to ut plus half at square, and v square minus u square equal to twice as, or v square equal to u square plus twice as, the same thing. So equation of velocity time graph we have known. We have solved some problems. So again we will be showing some problems. You have to do all the problems, right? So we have come across this, and what else we have? We have gone through the uniform circular motion. So circular motion, we have learned about this in the last class only. I think nothing much to discuss here. So not much thing are there. Only the velocity formula is given. So this is the velocity formula. V is equal to 2 pi r divided by t. 2 pi r means the circumference of the circle, right? So this is the length of the boundary of the circle. So 2 pi r divided by t. It is similarly, you can think like the distance by time only. So this is nothing but, if you think about like velocity, don't think this as velocity, you can think as speed also, because speed is equal to 2 pi r divided by t. Because this is not giving us direction, we can say that this is distance by time. V is equal to, V means speed equal to distance by time. This is 2 pi r divided by t. And what is the direction of this velocity? We call it velocity because it has a direction also. So this particular thing's direction is in the direction of the tangent of the circle. If it is moving in say this is clockwise, right? It is moving in clockwise, then the tangential direction is in the clockwise way. Okay, the tangent will give the direction of the velocity, and at every point the velocity is different, right? So we have done all this. So this was about the chapter only. So nothing much, we have to solve lot of problem on this. So we will do this now.